Okay, so today we'll begin the session with the periodic table again. Okay, see, in the last class we have focused on discussion of what? Like matter and atoms, elements, and little bit about compounds. Okay, and then next like mixture, types of mixture, homogeneous, heterogeneous. Next, now we are discussing about matter now. Like chemistry means anything like whatever we are using in our daily life. We are every day we will be dealing with this chemistry, chemicals only, right? So now how to express the quantities? Like if you take even small amount of any substance, it contains large number of atoms, right? It contains large number of atoms. So that is why we are using a term called a mole. So what this mole says is? Something like a dozen means 12, mole means Avogadro number. What is the number that equals to? 6.022 Yes, 6.022 into 10 power? Check whether voice is... Yeah, it's clear. Yeah. Okay, so now, so 1 mole means what we discussed? 6.022 into 10 power 23 particles. It can be anything. Okay, so now for example I am saying 1 mole of carbon. So what does it mean? It means 1 mole of carbon atoms means it contains this many number of carbon atoms. Okay, instead of saying this much big number, I am using the word it means what you can say? 23, 10 power 23 carbon atoms. Okay, right. Now I am asking you one question. Now in 1 mole of carbon atoms, how many electrons are present? How many electrons are present? Tell me. How many electrons are present? See, this many number of carbon atoms we have now. See, this many number of carbon atoms we have. In one carbon atom, how many electrons are there? Tell me first. 6 electrons, because its atomic number is 6. So you can say in 1 mole of carbon atoms, we have like Avogadro number of carbon atoms, and in each carbon atom we have 6 electrons. That is its atomic number. Right now, so Z into Na represents number of electrons or protons present in that carbon atom multiplied with that Avogadro number. Okay, it means 6 into 6.022 into 10 power 23. This many number of electrons are present in 1 mole of carbon. Is this clear? And is this clear now? Right. So now instead of saying 1 mole, I can also say it as 1 mole of carbon atom means what is its molar mass? 12. So 12 grams of carbon can be now considered to be 1 mole of carbon atom or 1 mole of carbon atoms or Avogadro number of carbon atoms. I can define in terms of grams, or I can define in terms of moles, or in terms of atoms. Okay, is this clear? Right. Now I am giving you only 6 grams of carbon atoms. So now tell me how many atoms. I want numbers. How can you do that? How much I am giving you? 6 grams. And what I am asking? Number of atoms. So tell me now. So first, do not get confused. First convert grams into number of moles. Then number of moles into number of atoms. This is very clear one. Okay, you won't get any mistakes here if you do like this. 6 grams means how many moles? Yesterday we have derived some formulas. I think 2 or 3 formulas we did. So tell me what are those formulas we did? I give an example, then we have discussed the formula. Tell me, number of moles means given weight of that substance by its molar mass, okay? Or you can say, write it as given mass by its molar mass. Okay, for carbon, tell me here, number of moles of carbon means given mass is how much? 6 grams. And what is the molar mass of carbon? 12 gram per mole. So it is 1 by 2 mole. So we got our number of moles now. Number of moles we got. So 1 mole means Avogadro number. Half mole means half into that Avogadro number. Okay, so it means half into mole means I can write 23. So you can write it as 3.011 into 10 power 23 carbon atoms. Now instead of asking like this, now I am making little bit different. I mean giving you 6 grams of carbon atoms. 6 grams of carbon atoms. Now number of electrons present in this. What I am asking, number of electrons. Tell me. So the same number. From here we got number of moles of carbon atoms. Then number of, like total number of carbon atoms we have. How many? This many. Okay. So that number into number of electrons in one atom is how many? In one carbon atom? 6 electrons. That's it. This multiplication gives you total number of electrons present in 6 grams of carbon. Is this clear? Same thing you can follow for number of protons also. Okay? Done. Next, shall we try one question? Yeah. Now, we'll be giving you 7 grams of nitrogen. See what I am saying it is? Nitrogen. Tell me now. 7 grams of nitrogen is given. First, find number of moles of nitrogen, okay, and find number of atoms. Number of atoms. See the question, you just see this what I have written here. Number of atoms of nitrogen. Number of nitrogen atoms. Yeah, tell me.
7 by 40.
Yeah, be conscious. Yesterday I have given 2-3 examples when I use this word. So now tell me number of moles.
7 by 1 by 3.
See, in the nature, how nitrogen exists? N2. So when we indicate only nitrogen, it means by default you consider it as N2. Okay, it should be considered as N2. Okay, if I take N2, what is its molar mass? 28. So see, if you take 14, it will be wrong answer. Okay, so it means whenever they say oxygen, nitrogen, hydrogen like that, what you need to consider? It as a molecule. Okay, if specifically mentioned as nitrogen atom or oxygen atom, then you consider it as its atomic weight. Otherwise, molecular weight. So now tell me number of moles here first. So 7, like given weight is 7 by 28. So it will be 1 by 4 mole. Okay, up to here it is clear. Now next what I am asking you? So number of atoms means what we know? Like formula type you tell me first. Number of moles into, in each mole Avogadro number of atoms like particles will be there. Which particles? N2 particles will be there. In one N2, how many atoms are there? 2 atoms. In one N2 molecule, atomicity is 2 now. So N into Na into its atomicity. Okay. So don't think that whoever came today for the first class, don't think we have discussed everything yesterday I am doing now. Don't think like that. It's very basic. I am repeating whatever I have discussed yesterday only. Okay. Right. Tell me here. Number of moles are how many? Into? Atomicity is how much? 2. That's it. So 3.011 into 10 power 23. So is this clear? Okay. I think I have given 2 questions in the last class. Okay, we'll come back to periodic table now. Everyone should say S block elements, P block elements, D block elements. Okay, before that let us finish that yesterday's question first. Yesterday's 2 questions, So we'll discuss now first. These two, no? These two we have discussed in the last class. The next, yeah, tell me about this. How many molecules of water present in 9 grams of water? First of all, a question అర్థమైందా మీకు? ఏం అడుగుతున్నారు? In 9 grams of water, how many molecules are there? First, what we need to find? Number of moles. So tell me, number of moles means? Given mass by molar mass. Okay. So tell me, 9 grams by 18 gram per mole. So it is 1 by 2 mole. Half mole we got. Okay. Number of moles is done. Now what they are asking, number of molecules. So number of molecules means? Tell me. Number of molecules formula means? Number of moles into Avogadro number. So half into 6.022 into 10 power 23. Is this clear? Okay. So now if I ask you the same, like in the same question, now I am extending the question. Tell me number of hydrogen atoms in 9 grams of water. How can we do that? Tell me in the forms of formula what we need to do. See, in 1 molecule of water, in 1 molecule, see, what is this final answer we got? Number of molecules, like number of water molecules we got, right now. So in 1 water molecule, how many hydrogens are there? So 2 hydrogen atoms are there now. So in this many number of water molecules, how many hydrogens are there? That number multiplied with 2. So it means Avogadro number of hydrogen atoms will be there. Is this clear? Okay. Okay. Is this clear or not? Tell me. Yeah. Now if I ask how many oxygen atoms are there? How to do? In 1 water molecule, 1 oxygen atom will be there. So this many water molecules means that number multiplied with 1. That's it. Is this clear? Yeah, that's it. Tell me for this question. Calculate the actual mass of water molecule in grams. How can we do this? Yes. See, calculate actual mass of water molecule they are saying. See, it means 1 mole water molecules, 1 mole H2O if I say. How many grams it is? 18 grams you know. Okay. It means 1 mole means how many particles will be there, water particles, molecules? Avogadro number. 6.022 into 10 power 23. This many number of water molecules will be there. So for this many number of water molecules, what is the weight? It means you just simply understand, you have taken that weighing machine and you are putting how many, this many water molecules you are keeping on the weighing machine, and how much weight it will be? 18 grams. For this many molecules, 18 grams. For one molecule, for one water molecule, consider it as X. Okay, now you need to find this X. So just use the unitary method. What I told you yesterday in the last class, like unitary method means something like X into this number, 1 into that number. Okay, like this. Okay, so it means X into 6.022 into 10 power 23 equals to 18 grams into that 1. Okay, so now I want X value, no? So X will be no 18 grams by 10 power 23. So this is around 3 times now. 6 means 3 times. So 3 into 10 power, see this 10 power 23 is in the denominator right now. So if I write in the numerator, it becomes 10 power minus 23. So this many grams it is. This many grams it is. Is this clear how we are doing? Yeah, done. Done with the 2 questions? Okay, right. Let's move for a periodic table. Why I am focusing on periodic table, see, it is easy to get at least 2 answers, I mean 2 questions in your final exam, if you know the periodic table exactly. Okay, for example, what are the elements in nickel family I am asking? How can you say? Like group. Yesterday we discussed or not? But you haven't practiced it. Okay, see. This is a short term course. You have just 45 to 50 days of time, maximum 45 days we can say. If you are not covering whatever the portion we have finished on that day, so there is no point of taking the crash course and all. Okay, you should cover at least whatever the topics that I have like discussed in the class for all subjects, you should finish that day itself. Okay, if possible, I told you to maintain your personal track also, it means personal schedule also, like what are the topics to be focused, by this time how many chapters I can complete from each subject, like that you should maintain, then only it will be fruitful, otherwise it is waste of time. Okay, so from day 1 itself you should be more consistent about your preparation. Okay, for first 1 week we just joined a few days back, so we will be consistent for 1 week, so slowly diluting it and thinking, hey, ఇది మనకు రాదులే అట్లా అనుకోదు. Okay, be consistent with your preparation. Okay, right, let us discuss the periodic table now once again. Where is this? Once try to write at least D block elements, everyone. Yesterday have you written that? Okay, so yesterday we have written S block elements, and the next P block elements we have written, in between we have also written D block, and I told you some names to remember them. See, you can remember this group as, see this group, in the last class also I have told, bag, it, how it is, bag, B-A-G, it, bag, it. Okay, in, if you want you can remember it also, bag it in, so you are keeping something in the bag, that is the 13th group elements. Okay, next one, carbon, silicon, germanium, tin, lead. Okay, so this one, nitrogen, phosphorus, you just read them fast, or somehow you need to remember them. Okay, it's completely up to you. If you are comfortable in Hindi terms, you can make one Hindi term out of it. If you are comfortable in English or any other language or Telugu, whatever it is, so you make one simple sentence out of it. Okay, like a mnemonic. Okay, it will be remembered. Okay, right, let's write once again. Tell me, what is the third like 3D series elements? 3D series elements, scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc. Okay, next, so yeah, tell me here 4D series elements, yttrium, zirconium, niobium, molybdenum, technetium or technetum. Next, this group you remember it as ferrous. What is that? Ferrous, ruthenium, technetium, ruthenium, rhodium, palladium, silver, cadmium. Okay, done. Next, this one, 5D series. Here it is lanthanum, here it is, tell me, hafnium, tantalum, tungsten, rhenium, osmium, iridium. Here in the last class, by mistake I have written here rhodium, if you see in the last class. So, but actually it should be platinum. Yesterday after going after the class I have seen. So this is a mistake we have written by mistakenly. So here it is rhodium, here it is platinum. Next silver, gold, Rm, Hg, mercury. Okay. Next one, I told you one trick here to remember. R, D, S, B, H, M, D, R, C. Just remember three things like RDS, BHM, DRC. So R means Rutherfordium. What is that? Rutherfordium. Okay. So this is DB, dubnium. Okay. S means Seaborgium. Okay. Seaborgium. Okay. Next, this one borium, hassium. This one is metnarium. This one is Darmstadium, DS. This one is Roentgenum. See, this one is Copernicium, like this. Okay, done. All 3D, 4D, 5D, 6D series over. Okay. See, when I say 3D series, which period these 3D series elements will lies? In which period these 3D series elements will lies? Tell me. Yeah. So remember, if I say 3D series, it lies in 4th period. Remember this difference. 3D series lies in which period? 5D series lies in 5th. This is 6th. This one? 7th period. Just remember this. Okay. Now, here I have represented lanthanum, actinum. See? So, which group is this? How many S block elements will be there this side? 2. Like if you want, you can just see here. S block 1 and 2. After that, like D block elements. Okay. Now, if you observe the numbers like 1, 2, 3, 4 like that. So, D block elements group number is 3, 4, 5, 6 up to 12 it is. Okay. Okay. So, now if you observe, this is third group. Okay. So, now third group, all lanthanides and actinides are lies in which group they will ask? And lanthanide belongs to which period they will ask? Actinides belongs to? Even yesterday also we have discussed this. Okay, why I am discussing multiple times? See, we are only focusing at this time as on basics. Even if you are not remembering this means it is very difficult because we can expect a question from here. Which group lanthanide belongs to? Which group? Which period? Actinides? 7th period? 3rd group. Okay, that's it. Yeah. So now you can remember this as a teaser I told you. Just as a like if we have something like rhyming, it is easy to remember. Okay. So this one chromo I told you. What is this? Chromo. This one has 1/3. See 1/3. VNTD. Okay, something like morning means what you will say, how you will type in the WhatsApp. MRNG, like you are getting some kind of understanding now. So here also you just make the mnemonic in your comfortable way. Okay. So next, what about this? This one is matrib. What is that? MTRB, matrib. Okay. So see, you should remember like this and also like this. For example, just now I asked you like what are the elements belongs to nickel family, and now I am asking you about iron family. Now what are the elements? I told you a word ferrous. Ferrous means what? Ferrous, like rose, like this I told you. Ferrous, like ruthenium, like ferrous, like R word if you get. So ruthenium, osmium, like that you can able to remember. Okay. So ferrous you can remember. Like even that is ending with like osh, like Ramesh, Suresh, how it will be? Like SH now. Here also you have H. Okay, you can remember like that. Okay, this one has NIPPD, NPPD. Okay, so this one, like I told you, Karim, CORIM. Okay, so I hope you can remember now. This last group you should remember, like zinc, cadmium, mercury, zinc, cadmium, mercury, and last one is copernicium. It's not copper, it is copernicium. Now copper here, copper, silver, Rm. See, these are precious now. So you can remember copper, silver, Rm or gold. Okay, you can remember like that. Okay, so this thing you can remember. Okay, that's it. So now, will you write this on your own? If I give 5 minutes, will you write? Yeah. one straight. Guys, those who are watching in live, so you can also try, you can also interact in the chat box. I will be looking into it. If you have any confusions, you can please mention in the chat box. Definitely I will respond on it. Okay. S block elements if you observe. So what is the valence electronic configuration for this? Like NS1 I can generalize it. Okay. So for this one, ns2. For this p block 13th group, see 13th na 3, so ns2 np1, so 3 here we have. Okay, so why this is 3? Because here 10 are there in between, just count, it will be 10. Okay, so that's why after 2 here you are going to get 3, but it is like a 13th group. Why? Because 10 d block like series is there here, like groups are there. Okay, next this one ns2 np2. Okay, right, for this one ns2 np3, this one ns2 np4, next this one ns2 np5, this one ns2 np6. Okay, so now if you observe from here to there, like 10 plus 3 13, 10 plus 4 14, like that, 10 plus 5 means, you just remember 15th group means how many valence electrons? 5. 16th group means how many valence electrons? 6. Will you remember that? No. How many valence electrons are there in nitrogen family? 5. In oxygen family?
6.
Halogens. What is that general electronic configuration? ns2 ns2 so now this is a valency electronic configuration. Okay, now there is one more term called valency. What I am saying? So this valency term indicates or says about the combining capacity of that element. Means what do we mean by combining capacity? That element is there now, that element will show some chemical reactions. Okay, so now with how many electrons, like what is the combining capacity of first group elements, they will ask. So this fellow, like halogen, like this alkali metals are there now. So by, see, in chemistry everything happens to attain stability. So in order to attain stability, they may react or they may do something, but finally what they will get? Stability. Even we are also trying something like this coaching and all to get some stability in our life right now. So this group, by losing this 1s electron, they will gain noble gas configuration. So in complete periodic table, which is most stable here? Noble gases. So all these other fellows will always try to attain this noble gas configuration. Okay, now this alkali metals loses how many electrons? See, for example, here I am writing lithium. So atomic number is 3 now. So you are writing 1s2, 2s1. So here, what about helium? Atomic number is 2. So you are writing it as 1s2. So it is 1s2 now. So similarly, to attain this helium gas configuration, lithium will lose this extra electron. Like that, sodium also loses that extra electron. So what is the combining capacity of these alkali metals? 1. Okay, so for S block first group elements it is 1. Similarly for this beryllium group, I mean the second group, 2. So valency for this is 2. Okay, so now if I ask similarly for oxygen family, what is your answer? What's your answer? See, they have 6 electrons now. How many electrons are there in the valency? 6. By gaining 2 more electrons, their octet will get fulfilled. Octet means what? See, ns2 np6. What is the total count here? 6 plus 2 is 8. So all these fellows will try to get that 8. Okay, by how it is possible? By gaining. These fellows are by losing and these are by gaining. So now that's why what is the valency of this oxygen family? 2. You can say it as 2. So is this clear? Okay, valency electronic configuration is different and valency is different. Valency means it is a combining capacity of that particular element. Okay, right. See, for nitrogen family how many we have? 5. So by gaining 3 more electrons, it attain octet configuration like that. Okay, done. Next, yeah. So here, so see this, read this line once. Valency of an element is determined by number of valency electrons. For oxygen there are 6 valency electrons. So in order to get that octet configuration, 2 electrons are required. Like that, based on valency electron count, we can say it's valence, combining capacity. Okay. So now, next. So in a group, what happens to the valency? So for all the nitrogen group elements, it is same. But in period, valency increases up to 4. It means up to carbon, it is increases, carbon family. Then again it is decreases, because for carbon, it can combine with 4 other elements right now. So the combining capacity of carbon is how much? 4. Like combining capacity of carbon family is 4. Okay, it means its valence is 4. Now from nitrogen, oxygen, like next what? Fluorine, like this. If you see, this is 3, 2, 1. So it is decreasing now. So from here it is 1, 2 we have seen, it is going up to 4. Then again it is so that is what the line says here. Okay, the next one, atomic size. Okay, so atomic size, these are something called periodic properties. What do we mean by periodic properties? You have written for 8 marks in your first year. Tell me, what is that? Periodic properties means what? There are something like their sizes, are there some chemical properties or physical properties changes periodically. It means from up to down or from left to right, there will be some variations. Okay, those are considered to be here periodic properties. For example, size, atomic size or atomic radius if I say. See, radius, bigger the radius, bigger will be the size. So now tell me, what happens to the size down the group?
Increases.
Okay, increases. Why it is increasing? See, what you are writing, this has 1s1, this is 2s1, this is 3s1, this is 4s1, like this now. Only this n value is getting increased, yes or no? This 5, 6, 7 like that is increasing. So what is this n, like these numbers are saying? See, what is general electronic configuration you told? NS1. So this n value is increasing as we go down the group right now. So if this is a nucleus, okay, so this is n equals to 1, n equals to 2, n equals to 3, like that. What is happening here? So as n value increases, the radius also increases. So down the group, what happens to size? Increases. This is clear. Next, from left to right, it means from S block to P block. What happens to size, they will say. So in order to understand this properly, tell me, what is the electronic configuration of this second period elements? Like this is 2s1 you are writing, this is 2s2 you are writing, this one is 2s2 2p1, this is 2s2 2p2, this one 2p4 2p5 2p6, like that we are writing. See, if we go from top to bottom, this n value is increasing, it becoming 1 2 3 4 like that. But if we go from left to right, that n value is being same number. So if we go from left to right, it is being n equals to 2 only for second period right now. So it means all that newly added electrons are coming into this second shell only, yes or no? So if this second shell only that electrons are coming, what happens? See, atomic number is how much here? 3, 4, 5, 6, like that number is increasing now. See, atomic number is nothing but number of protons and also it is equals to number of electrons also. See, electron count is increasing, but inside the nucleus number of protons also increasing, yes or no? Here only 3 protons, 4 protons, it means positive charge is increasing from left to right now within the nucleus, like number of protons increasing means. Now what happens is positive charge will attract these electrons now, because electrons means negative. So now what happens, these since electrons are lying only in second shell, that all that negative charge will be attracted by the nucleus more effectively, yes or no? So now what happens to the size? So from left to right, what happens to the size? Decreases. Okay, because the newly added electron is entering into the same energy level, that's why size decreases, you can remember. Okay, these are the 2 lines we have seen here. Okay, atomic size directly proportional to shells. Shell number is indicated with the number n, that is what we are calling it as a principal quantum number. Okay, next, what about group? So atomic size increases down the group. Is this clear? Right, let's move forward. Yeah, so this is about electronegativity. Yesterday we discussed, what do we mean by electronegativity? Tell me once again. Tendency to attract bonded electrons towards itself. For example, there is AB molecule. having a covalent bond between them. So bond means how many electrons? Okay. Bond means how many electrons? So now these 2 electrons dragged by only one element. See, this is a covalent bond now. So electronegativity is given in covalent bonds only, first of all. So now once again I will define this. The tendency to attract the bonded pair electrons in a covalently bonded molecule is called electronegativity. It means the tendency of, let us say, the tendency means what? Atruta andam kada. Atla. Okay. So the tendency to attract the bonded pair electrons towards itself. Let us say A element is having more tendency to attract bonded pair electrons towards itself. Now these electrons will lie which side? A side. So it will get a partial, electrons means positive or negative? Negative. So partial negative charge on A, and this will be like that. Okay. So who is having more electronegative? R. So that element will get a negative charge. The other will get a positive charge. Is this clear? Okay. So now all these elements are metals. So metals are electropositive. What I am saying? It means electropositive means they have tendency to be in positive nature. Okay. It means these fellows, whenever they react with anything, they will be in the positive charge. For example, sodium element is there. It is exposing to air. To what it is exposing? Air. Now what happens? This fellow will stays in which state? Positive state. How many extra electrons it has? One. So it will be now in Na plus. Okay. So now I have sodium metal. Now I have brought this and kept in the atmosphere like air. So now what happens? It will react with the air and it will form oxides like Na plus O. But oxygen, now just now I told you what is the valency of oxygen? 16th group now. Valency is 2, valency electrons are 6. That's why I told you clearly. Okay. So now how many electrons are there with oxygen? 6 are there. So it required 2 more electrons now. That's why it will be like -2. Okay. So now try to balance these charges. Here +1, this is -2. How can I make that equal? So I should take this NAs as 2 Na. Na plus and Na plus. One oxygen atom. So it will form Na2O. Sodium oxide you can say. Is this clear? Okay. So similarly with anything, if these alkali metals are exposes, what they will do? They will exist in +1 charge. It means they loses that electron and they will be in the +1 charge. Okay. Right. Is this clear? Okay. Similarly second group elements also loses electrons. But how many loses? 2 electrons lost by this, and whoever is reacting they will gain that 2 electrons. For example, it is exposing to oxygen only, let's say. So magnesium loses 2 electrons, one oxygen will take 2 electron. So here I can say MgO is formed. Okay, now you can balance. How many oxygen atoms are there here? 2. Here only 1 you are seeing now. So you can write here 2 MgO. So you can take here 2 Mg plus 1 O2 gives you 2 MgO. Here also try to balance this. Na plus O2 gives rise to Na2O I am saying. How can you balance this? 2 Na, this is fine. Next. See, this is 2 oxygen atoms, here only 1 oxygen atom there. Tell me. So I can either write here 1/2. 1/2 O2 means how many? 1/2 into 2. It means 1. So it can be written like this, or I don't want all these fractions. Now what I can do? I can multiply this complete equation with 2. Now what happens? Tell me. 4 Na plus 1 O2 gives rise to 2 Na2. Is this clear? Okay. You can balance like this. It's a very basic thing. Okay. Now if you see this table, this is called Pauling scale. Okay. He is a person who given electronegative values. Okay. So now see who is the most electronegative element in the table? How much it has? 4. Okay. So now in the table who is most electropositive? Cesium, how much it has? 0.7. So this is most electropositive. See, electropositive, electronegative, opposite terms only now. Okay, if it is least electronegative, that means it is most electropositive. So this is most electropositive, this is most electronegative. Now if you observe, fluorine is 4.0. Oxygen is how much? Chlorine. So second most electronegative element? So 3.5 now? Oxygen. Next, third most electronegative element if I ask? Nitrogen and chlorine. So on Pauling scale, you can remember this statement itself. On Pauling scale, electronegativity of nitrogen and chlorine are almost equal. Okay, how much it is? 3.0. Remember this number. Okay, next, like this, you need to remember the values. Means it is difficult. At least approximate order you need to know. Okay, tell me here, sulfur, how much it is? 2.5. Carbon also almost 2.5. Next, phosphorus? So now you have observed something. So as we go down the group, what happens to electronegativity? Decreasing. Okay, from there to this side, left to right? Increases. Remember this. Now let us see some simple questions. Okay, so after the class, you can take these notes, this table. Okay, right. Give me this answer. Very simple, based on your table itself. Okay, so tell me. Second one. So highest one we know is fluorine. Second most I told you. Which one? That's it. Nothing to worry here. So directly you can see. That's it now. Next. This one. See, down the group what happens to size? Increases. So down the group size increases, but left to right? See, again I am saying, we will discuss these things again in periodic table chapter and all, but in the next class onwards. But here, if you observe, you are there here, so instead of wasting time, I just wanted to give you the concepts. Okay, I will again discuss. If you are unable to understand, you ask me now. Okay, or do not worry about that. You come after the class and tell me these are the issues I have. Like that you share me, I will go with that pace. Okay, now tell me. See, if I write like this, what is happening, you just tell me. This red color represent nucleus. It has positive charges, protons and neutrons. Okay, and this white color lines, orbits in which electrons are revolving. Okay, so now let us say here some 10 electrons are there, ma. How many electrons? 10 protons are there. Now positive charges, negative charges equal now? Yes. Now if more number of electrons are there, like 15 electrons are there, let us say, and 10 protons only there. Now tell me what is the scenario? 5 electrons are more now. Who is dominating now? Who is more now? Electron count is more. If electron count is more, where that electrons will lies? In these orbitals. So now since if positive charge is more means that will attract the electrons. But who is dominating? Electrons. So that electrons will expand, like they will repel each other. If two like charges are near to each other, what happens? So they will expand like this. Okay. So for example, A is an atom. I am saying atom. If atom having a negative charge on it, you should call it as anion. Which ion? Anion. If that atom contains positive charge, you should call it as cation. So atom, anion and cation. Is these three terms are clear? Okay. So now when I say anion, in anion case who is more? Electrons are more. Now the third scenario here I am saying, it has just 5 electrons. How many electrons? 5. But 10 protons are there. Now tell me what is the scenario? Nuclear charges are more now. So positive charge is more. What these positive charges will do? That they will attract that electron cloud. So now what happening to the size? Decreases. Size is compressing now, decreasing now. So if I give you a cation, atom and anion, always the size of anion will be larger. Okay, and always size of that cation will be smaller. So is this clear? Sizes? Okay. Now I am giving you nitrogen atom, nitrogen cation, nitrogen anion. What is the size order? Who is more, who is less?
Power minus 3 is more.
Like this is clear. Now I am writing P plus 3, P plus 5. Size order, who is more? More is a nuclear charge, more is a nuclear charge, smaller is the size. So nuclear charge inversely proportional to size is inversely proportional to will you remember this? Now come to this. Which are the following order is correct about ionic radius? See, when I use atomic radius, it is discussing about atoms. When I say it is ionic, it is discussing about anion and cation. So for a particular element, always anionic size is larger, then its atom, then its cation. So more is a negative charge, more is a size. More is a positive charge, smaller is the size. Remember this? Yeah. Now tell me, what is the answer for this? First one. Sir, how to compare first of all? Titanium, manganese belongs to 3D. So scandium, titanium, vanadium, chromium. So that belongs to 3D series. Okay. So now generally what happens from left to right? Size? 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 Everyone decreases? Okay. It is if the same elements, that is if the like this, if they are in atomic form, it is decreases. Now it is already decreasing. Again, if there is a charge something like this, plus 4, if there is same charge, that case also who is smaller? No? Manganese is smaller, because left to right what happens to size? Now you got some clarity. Now I am writing here plus 7 size. Now tell me, who is having smaller size? Manganese. Why manganese? More nuclear charge. That's it now. So this is smaller size now. That's it. So tell me, is this correct? Whatever they mentioned? No. Wrong. So they are saying correct order. So this is wrong. Next one. We will come back to this. Go to this. Cation is there, anion is there. Now, what is the atomic number of potassium? 19. What is the atomic number of chlorine? 17. These are their atomic numbers. Okay. So now, potassium atomic number is 19. I am removing one electron. Now how many electrons are there? 18 electrons only there. But 19 protons are there inside. Okay. Chlorine is 17. By adding one electron, it becomes a chloride ion. How many electrons are there? 18. So now what it is? Anion. See, it has 18 electrons, 17 protons. Who is more? So electrons are more now, what happens to size? Increases. And if you consider here, same number of electrons are there now, both in the ionic forms, 18 and 18. So if we are comparing different species having same number of electrons, we should call them as isoelectronic species. What is that? Isoelectronic. So for isoelectronic species, it means species with same number of electrons, always anion, greater the anionic charge, greater is its size. Okay, now tell me, out of these two. Chloride ion is a greater size than potassium cation. Okay, so did they mention it in the correct way? No, remove this. Next, what about this? Just now we discussed P plus 3, P minus 3. Which is larger in size? P plus 3 should be larger in size. Okay, this is correct. Okay, this is perfect. Okay, now if you think about this these things, chlorine, chloride, chloride. So both of them are chlorines only now. So what makes the difference? Charge is same only. This number, what is this number? What is this numbers? Yesterday we discussed. See, element is represented with symbol X. Here I am writing Z, which represents atomic number. Here I am writing A, which represents a mass number. So these two numbers are what? Atomic mass. Okay, and if I write something here like minus, minus, plus like that, charge, and if I write something here, atomicity, we discussed this. Okay, so now here two different masses we have now, so there is nothing to do with mass. Okay, so isotopes have same sizes, almost same sizes. Is this correct now? No, so they have mentioned it as not equal. So it means which is the perfect answer? Is this clear? Okay, so isotopes have same size. So now what do we mean by isotopes? How do they differ? Different atomic mass. Why they differ in atomic mass? Number of protons are same. Atomic number is same now. It means number of protons are same. But neutrons are there now. That varies. Here 2 neutrons are less. Here 2 are more. Okay. Answer these questions. As we move down the group, atomic size increases, but they mention decreases, so incorrect. Next, this one, non-metallic character, non-metallic. See, what happens to metallic character, you tell me? A metallic character increases now, so non-metallic character decreases. What they are saying? So this is also wrong. Next, this one, metallic character, so it is perfect now. Yeah. Next, this one, nuclear charge increases or decreases? So nuclear charge, as we move down the nuclear charge, here you can say nuclear charge now, you can say it as increases. Okay, like protons are increasing now, count. Okay, based on that. Okay, next, this one, so which is answer? This one, element with maximum metallic character. Which one? Rubidium. So down the group, metallic character increases. Next, the total number of vertical columns in the long form of periodic table.
18.
Vertical. 7. Vertical means what? Vertical, na? Sorry. So these are horizontal rows or vertical columns. Vertical columns are how many? 18. Okay, this we will discuss in the chapter. Now we will discuss a few more things. Isoelectronic species means what I told you? So now let us have some discussion on chemical bonding also. So see, chemical bonding. Okay, see, what do we mean by bonding? The attractive force which holds together the constituent atoms or ions of a chemical species is known as it may be anything that holds two species together is considered to be chemical bond. Okay, what I am saying, it can be anything, like any type of force that holds two atoms or species together considered to be chemical bonding. Okay, so now why this chemical bond formation happens? Anything, what I told you, in the nature happens to gain. So nature loves stability. So that's why these chemical reactions are taking place. Okay, because if there is anything unstable, they want to settle in their career, like you. So that's why they make some chemical reactions and attain. So that's what. Next, elements try to attain noble gas configuration and attain stability. Okay, so now these elements try to attain noble gas. So this trying can be happened by losing the electrons, or by gaining the electrons, or by sharing the electrons. What are the three ways? Gaining, losing, sharing. Okay, so now it can be happens. See, transfer of electrons. It means that fellow completely loses its electron, like transfers the electrons. So whatever he has, out of that some will be shared, I mean completely donated, like transfer. Transfer means you can say completely transfer, I mean given. Okay, so which elements will make that kind of scenario? Where do you see that? S block elements, like sodium will transfer its that extra electron and becomes plus. Okay, by transferring one electron it becomes a cation. To whom they will transfer? Something like the species who require that electron. For example, halogens if we take, like fluorine, chlorine if you take, they have 17 electrons. So in order to attain that noble gas configuration, one more is required. So that one more is taken by this fellow and becomes? Okay. So now here positive charge, negative charge. So there is some opposite charges will, what they will do? Attract each other. So there is electrostatic force of attraction which holds these two ions together and they will form a compound. So like NaCl is formed. Okay, so this is like complete transfer of electrons, it is taking place now. So by doing this, the compound formed generally considered as ionic compounds. What they will? So now who will transfer the electrons? Metals. Who will gain that electrons? Non-metals. The bond formed between a metal and a non-metal is ionic bond. Remember this. Okay. Next one. Mutual sharing. So there are some elements, they will mutually share the electrons. For example, if an element is combining with itself, let us say chlorine, how many electrons are there? 7. Na? Let us put 7 dots. 7 dots indicates each dot 1 electron. So 7 electrons. Seven electron. Okay. So now how many extra electrons it requires? One more is required. For this one also? So now what they will do? They will mutually share each other like this and they will make a bond like this. So now count. Each element will be having a 8. So 6, 7, 8. This one also 6, 7, 8. So both become stable. So that's why in the nature some elements will exist in combined states, like instead of like carbon will exist independently, but here chlorines, hydrogens, if you see hydrogen molecule, because in order to get helium gas configuration, and chlorine like halogens diatomic form. For oxygen O2. Now look at the oxygen case. Oxygen, how many electrons are there? Valence electrons. 1, 2, 3, 4, 5, 6. Still how many required? 2. One more oxygen you take. Okay, so they will mutually share. They will exist like this. Is this clear? Okay. Now, once again, nature loves. So in the nature we have water now. So water is a stable molecule now. If it is stable, that will be formed right now. So now see, hydrogen require, how many electrons hydrogen has? Hydrogen has 1 electron. Now how many electrons hydrogen required to gain stability?
1.
That should be called as a duplet configuration. What is that? Who is his friend? Helium. If he gains the electronic configuration as helium, that will become stable. Whereas other elements other than this hydrogen, they will try to attain octet configuration, like 8 electronic configuration in the valency. Okay, so let us say oxygen. So oxygen will try to gain neon gas configuration. So how many electrons oxygen has?
6.
So 1, 2, 3, 4, 5, 6. 6 electrons I am writing. How many required for this?
2.
So this side 1. How many over now? 7 it become. So 1 more. 8. So now oxygen is happy, hydrogens are happy, and we are also happy because of water. Okay? So that's why water molecule exists in the nature. Okay, are we preparing them synthetically completely? No. We have enough amount in the nature, and if extra required, we are purifying them, that's it. But we are not creating synthetically in the labs for drinking right now. Next, mutual sharing is over. Next one, if you see, donation of lone pair. See, there are some molecules. For example, ammonia means how you are writing? NH3. See, if you write only like this, how many electrons are there, tell me? One hydrogen can make only one bond. One bond contains how many electrons? Now tell me, how many bonds are there? 3 bonds means?
6 electrons.
But in order to form that molecule, we know it has 8 electrons. Okay? Because nitrogen valency, how many electrons are there? Nitrogen valency? 5. Okay? Don't say number of equal to atomic number. Okay? It is 7. 5. It is 5. So now, how many bonds it is making?
3 bonds.
So extra? 1 lone pair. Okay? This is non-bonding electrons we can say, or lone pairs we can say. Okay? Now when I say about third group element, like boron is third group element now, how many valence electrons are there? 13th group element means 3. So 1, 2, 3 let us write. Okay? So now only valence electrons are how many? 3. So even if it is making, how many bonds it can make now? 3 bonds only it can make. So 1 bond, 2 bond, 3 bonds. Even after making 3 bonds, it has now how many electrons? Now in overall, in BCl3 molecules, chlorines are happy because they got that extra 1 electron and they are having octet configuration, that is fine. But what about boron? Check once, 3 bonds means how many valence electrons?
6.
I mean total count in this molecule, 6 only. But in order to get octet, how many it requires?
8.
So it is less than that octet configuration now. So I can say this as electron deficient. What is this? Is it deficient or not? Deficient by how many electrons?
2 electrons.
So this fellow is poor, deficient. Now what it will do? It will try to take the 2 electrons from his friends. Okay, so the person who is giving the 2 electrons is someone who is having more. Like here, extra like non-bonding electrons are there now. See, this complete 2 electrons are given by one fellow only. So the bond resulting after donation of pair of electrons to this species is called a day 2 bond. What is that? See, donation of lone pair of electrons. Who is donating? NH3. This fellow is accepting. So the bond resulting after this formation, like you should represent like this. See. Okay, for better understanding, you tell me what is the valence electronic configuration of boron? Let us write completely. 1s2, 2s2, 2p1. Okay, so for one bond formation, 1 electron from each species is required. So totally in one bond, how many electrons are there? 1 bond contains how many electrons? 2. Okay, so how many bonds it is making? 3 bonds. It means there should be 3 unpaired electrons with the boron right now. So from here 1 electron jumps there. So that what happens? 1, 2, 3. That's it now? Okay. So this is with 1 chlorine, this is with another chlorine and another chlorine. Over 6 electrons done. Okay, we have one empty vacant orbital, just check here. Yes, so with the boron in BCl3 there is one vacant orbital. If I also write 2 more electrons over here, it becomes, how many electrons it becomes? 8 electrons, no? Arey, you are not getting, I know. 3 electrons with a boron. Say chlorine has 7 valence electrons, 1 is required. So if this electron is shared mutually, then chlorine become 8th electron, like chlorine's 8th electron will be taken right now. So all chlorines will get like noble gas configuration, yes or no? Now this electron is mutually shared now from chlorine also. So check once, 1, 2, 3, 4, 5, 6. 6 over, 1 vacant orbital is there. So only 6 are there, still how many it required? 2. So to this empty orbital, if someone is donating, it will become octet. Okay, so if no one is donated, it can be considered to be electron deficient. Okay, so now NH3 having lone pair electrons, boron is having empty orbital. So this is how electrons are donated. So you can write NH3 BCl3 like this. The one who is giving the electrons should be represented like this, and this bond is called coordinate covalent bond or coordinate covalent bond or simply day 2 bond. Okay, so this is the scenario, that's it. Okay, now one more thing you can remember. What is this? Electron. So that electron deficient species is accepting pair of electrons. Now you can call it as a Lewis acid. What is that? Lewis acid. One of the most generally seen question, identify Lewis acids from the given examples. They will ask like this. So it can be considered as Lewis acid. So now tell me, how can you define in simple way what do we mean by Lewis acids? Electron pair acceptor is the species accepting electron pair, no? So this can be considered as electron pair acceptor. So it's a now this fellow is donating electron pair. Electron pair donor, Lewis base. Okay, pair of electrons are donated. So this is called. Okay. So now tell me water. I am writing. So it has like this. Tell me whether it can act as Lewis acid or Lewis base. In order to act as Lewis acid, it should have some vacancy, deficiency should be there. Then only it can accept the electron. Here all electrons are already, orbitals are already filled. So how it can accept? There is no possibility for accepting. So it cannot be Lewis acid. But it has a lone pair electrons now. This can be given to other electron deficient species. So I can say it as a Lewis base. So water can be Lewis base. Okay, about acid base theories I will explain in the equilibrium chapter. But is this clear? Lewis acid, Lewis base means basic one. Next. Okay. So now we have the types of bonds here. So now see, once again read the definition. The attractive force which holds together the constituent atoms or ions in the chemical species is considered to be chemical bond. So types of bonds, ionic bond also called as so how this ionic bond formed, I told you, between a metal and a non-metal by complete transfer of electrons from metal to non-metal. That's it, this is done. Covalent bond means mutual sharing of electrons, this is also done. Coordinate covalent bond means only one fellow will donate a pair of electrons and make the bond formation. Coordinate covalent bond is done. So metallic bond means it is present only in the metals. Like we are seeing the metals like iron, copper and all these things. Okay. So if you take a iron surface or any metal surface, there will be surface means it is built up of what? Atoms only, no? So each atom has nucleus right now. So around this nucleus we have some electrons inside and some electrons in the valency. Like for example, what is this inside and outside? For example, carbon if you are writing like 1s2, 2s2, 2p2. See, these electrons like highest n value is there now. Only these electrons participate in chemical reactions. So these are considered to be valency electrons. These are inner electrons. or I can say core electrons. What is that? These inner electrons or core electrons won't participate in chemical reactions. Only these outside electrons only participate. So these inner electrons are core electrons, these valence electrons are participating in the reaction. Similar to these, metals also have inner electrons, valence electrons. Now see, I am using a word kernel. What I am using? So kernel means that inner electrons are there now, inside electrons which won't participate in bond formation. That inner electrons plus that nucleus is there now. Nucleus inside, around that nucleus some inner electrons will be there, and outside we have valence electrons. That nucleus and inner electrons together called as kernel. Okay, so now here we have kernel and valence electrons. Kernel and valence electrons. Okay, so now what you mean to understand here is, this positive charge can attract the valence electrons of this adjacent atom, and this fellow can also attract the valence electrons of this atom. Like that, each atom has some attraction between the one positive charge and the other electrons of the other element, like that other atom, right now. So that resulting to form as metallic bonding. Okay, about metallic bonding and effects, what are the factors affecting it, we will discuss later again. Okay, and hydrogen bonding, this thing I will explain later. It is very important, hydrogen bonding. Okay, next. Okay, already we have studied about a Lewis dot structure almost. Okay, so in Lewis dot structure, what he is saying, electron is considered to be a dot. Okay, now whatever the valence electrons are there in an atom, that should be indicated as dot around that atom. Okay, so in a molecule formation, only outer shell electrons, valence electrons will take part in bonding. Okay, so Lewis symbols, an element is shown with its symbol and dots representing the for carbon, how many valence electrons are there? So 4 dots. Okay, hydrogen, how many electrons are there? 1. So it will make one bond like this. Okay, like that, how many it is possible?
4.
So that carbon will get a 8 electron. This is called octet configuration, and hydrogen will get a 2 electron, that is called duplet configuration. Okay, that's it. Okay. Now, done. Once read that statements. Yes, tell me. Every atom tends to attain noble gas configuration. This is known as octet. Only 2 electrons are needed, like hydrogen and helium. It is known as conclusion. Only compounds that follow octet configuration is considered to be who told this statement? Lewis. What he is saying once again? Only those compounds or molecules attaining octet configuration are stable. This is what the basic consideration he did. See, when we are studying about atoms at the early stage, you just imagine someone has to start explanation about molecules, how they are existing, all these things. That is what the scientist will do generally right now. Okay, and he is the first person who is trying to explain about the molecules, how the structure and all these things. Okay, so what he told, I will consider the valency electrons as the dots, and when the dots of one atom and the other atom completing its octet configuration, then that will be stable. If it is not equals to octet configuration, that is unstable. Like that he considered. Okay, the basic consideration is okay, to some extent is acceptable. But there are some compounds. For example, BCl3 is a compound. Is it existing or not? Yes, it is existing. But how many electrons it has? Just now we discussed in the last slide. Only 6 electrons are there. So is it octet configuration? No. Even it is not having octet configuration, it is existing. It means, can we say this is the limitation of his octet explanation? It means it's a drawback only, no? Yeah. So there are some compounds existing which is having electrons either less than the octet, or some of them are having greater than the octet. They are also being existing. Okay, it means those are the limitations. Okay, I can say expanded octet or deficiency in the octet. Okay, let us see. Incomplete octet means there are some elements like beryllium, boron can form stable compounds without 8 electrons also, but they are existing. So this is a limitation of so next one, expanded octet. For example, PCl5 if you consider. So tell me, phosphorus which group element? 15th group. How many valence electrons? 5. Okay, 5 dots you put like this. Okay, after that PCl5 means how many chlorines are there? 5. So let us put one chlorine with one bond, one electron for each, like this. So like this you have written. Okay, so now tell me how many electrons are there in count?
10.
So 10, greater than octet now. So we can say it as an expanded octet. But it is also existing. Okay, it is not following octet rule, but it is existing. Can we say this is a limitation or the failure of octet? Okay, next, what about this one? It has 12 electrons. Okay, it is also having expanded octet. Okay, that's it. Next, now what he told, the molecules or the atom or the species having octet configuration or noble gas configuration are stable, they are saying. But there are some compounds. For example, xenon is there. Xenon belongs to which group? It's a noble gas now. So noble gas means it should be stable. It should not show any chemical reactions right now. But that xenon is forming some compounds. For example, xenon, XeF2 or XeOF4, some different compounds are possible by xenon. So it means this is also a limitation of octet rule. Okay, these are the 3 limitations you should remember. Okay, remember. Next, yeah, identify this. Okay, now one more thing. What are the limitations of Lewis dot structure? Means what are the things we discussed? Tell me clearly. Expanded octet, incomplete octet, noble gas is also showing some chemical reactions. Okay, these are the 3. And one more thing, he just taking the dots around the atom and putting some random atoms around it and fulfilling the octet. Will it give us exact structure of the molecule? No. So he is unable to explain the structure of the molecule. And the next one, something like magnetic moment is there. Some are paramagnetic, we are saying diamagnetic. So did he explain that? No, that is also a like a limitation or drawback, you can write them. Okay, right, next one. Tell me what is the answer for this? Among the following, which is violating octet rule? Why? We already discussed. Huh? Okay, next, these 3. Where is PCl5? Hurry. It's a PCl? Tell me now. How do you write the structure? First you try, once take one pen paper and write it. ఇప్పుడే చెప్తున్నా, జస్ట్ ఇట్లా సినిమా షో లాగా చూసుకుంటూ కూర్చున్నారు అనుకోండి, ఏదో అర్థమైనట్టు ఉంటుంది, బట్ వెన్ యూ పుట్ ఇట్ ఆన్ ద పేపర్ won't able to do that. So always try to do it at least once. Okay, so once after completing the class you should go through the that notes so that you will get complete clarity. Okay, I will ask you to summarize the class that we have discussed at the end of the session and at the beginning of the next session also. Like today what I started asking you about what we discussed in the last class. Tomorrow also I will ask what we discussed in the yesterday's class. It means today's class. Okay, so before I enter the class you please go through the slides, I mean notes, and be prepared. Okay, it will be like gives me some boosting that yes, these fellows are following something, so I can teach them little more. Otherwise if you are having the dull faces, are Indra Babu ఇది అనుకున్నారు అనుకోండి, so I will also give like that. Okay, you should be energetic so that I can give a more. Okay, tell me what is the answer for, like, how you will draw these things. Once try them. Fast. Done? Now my question is, number of lone pair electrons and bond pair electrons in NCl3. Wrong. What is my question? Number of lone pair electrons and bond pair electrons in NCl3, I am saying NCl3 in complete molecule. 3 bond pairs, correct. Lone pairs you tell me now. Be conscious. Once again redraw the structure. Okay. Once again try it. See, some are saying, but I want to answer with confidence. Just draw the Lewis structure, you will get. Properly you draw for all the elements. Don't do randomly. So you are only seeing nitrogen. What about chlorine? Ten lone pairs? Yes. How many of them are 10? 10, answer 10. Okay. How can we draw this? See here, nitrogen, 1, 2, 3, 4, 5. Okay. So put one chlorine here. Now chlorine, how many electrons are there? 7 means 1, 2, 3, 4, 5, 6, 7. Like that, 3 chlorines. Seven. Okay. So one pair, second pair, third pair. Okay, 3 bond pairs we got. What about lone pairs? See here, 1 lone pair, and each chlorine 1, 2, 3. So 3 chlorines are there. So 3 3s are 9 plus 1 nitrogen lone pair. So 10 is your answer. Okay, is this clear? Okay. So this is one of the favorite question in EAPCET. And favorite means that fellow repeatedly asks. If you go through the papers, you will get. So you can do it for these 2 things also. Okay, tell me for this one, SOCl2. I'm asking for SOCl2. PCl3 same, looks like NCl3 only because same group, no? Yeah. Next, SOCl2, how you will draw? Fast. Done? Yeah. So you can write sulfur, which is central atom here. How can we decide? Yeah. So deciding central atom also important thing. So firstly, consider the electronegativities. that should be having a less electronegative and more more valency, like bigger size. Okay, so out of this less electronegative, this one, and its valency also more, it can expand its valency also, because third group element now, not third period element now, that's right. So sulfur 1 2 3 4 5 6. Okay, so chlorine has how many electrons? 7. So chlorine, 1 bond. How many chlorines are there? One more chlorine let us put here. Done. Okay, next one, oxygens. Oxygen, how many are there? 1 2 3 4 5 6. Okay, check once, all atoms are 88. I mean this red color, chlorine 88, oxygen 8. Done. Next sulfur, check once, 1 2 3 4 5, sorry, 1 2 3 4 8 9 10. Okay, 10 electrons we got. Okay, so now if you properly write the structure, it will be something like this. For understanding purpose I am writing like this. Okay, so now you can tell me how many lone pair electrons on the central atom of SOCl2? 1. This is the answer when I mention it as central atom. Or if I ask oxygen atom means 2 lone pair. If I ask in the compound means, how can you do this? 1 2 3 4 5 6, sorry, 3 plus 3 6 7 8 9. So 3 9. So this is your answer. Is that clear? Okay. Okay. Next, tell me for this. PCl5. For other things, incomplete octet means? Then what about this one? It is also like duplet. It is also not exactly incomplete, you can say, but only one answer they will ask now. So you can just choose the BF3 or BCl3 or whatever it is. Okay. Species with octet configuration? CCl4. Tell me this one. What's your answer? Which of the following contain both ionic and covalent bond? Write the structure properly for each of them. Structure means you just connect the bonds. That's it. You will get the answer easily. The types of bonds we discussed now, that lines you use here, you will get the answer. Next. Okay. So remaining thing we'll discuss in the next class. So just go through the notes or whatever the lines you have written and give me quickly what we discussed in the class. Just take 1 minute and go through the lines, whatever you have written. Done? Yes, I want them in the flow, like where we have started and where we have ended. In the order you tell me what we discussed in today's class. Firstly, we have discussed the 2 questions from the last class, that is from mole concept. Then next, periodic table, that D block elements. Okay, now the next what I told you to do? No, first revise them properly and write it once, okay, and after lunch also you revise it once. By the end of the day you should get this complete periodic table. It means S, P, D block elements you should get. Okay, for F block we will again have some other day, okay, because all one day means it will be difficult. Okay, do this. Next, after this, periodic properties, okay, sizes and all those things. Electronegativity, that electronegativity table will be there here, just go through that once again, that values. Okay, next, trends, like how electronegativity varies, all those things. Next, chemical bonding. Chemical bonding, here types of bonds we discussed, how the type bonds are formed we discussed. Okay, next, Lewis dot structure and its limitations we discussed. Okay, some questions related to it. Next, what is that? Next, identifying number of lone pairs, bond pairs in a given molecule. That's it. Okay, now the questions related to these will be there. Here I have multiple slides loaded here. You can just go through these slides. Okay, I will save there. You can go through these slides in the evening study hour time. You can do this. Or else I have given you 30 questions yesterday's class. I mean in the study hour, evening. Yes or no? I told you where it will be also. You can just open it and you can keep practicing them. Okay, that's it. That's it. We'll end up the class first.